Okay guys, in this video we're going to learn how to find the molar mass. Okay, so the molar mass, it is a specific conversion factor that switches between grams and moles. It is found by adding the average atomic masses of each element in a chemical formula. So that will be given to you for the problems that I'm asking you to do. You're not finding your own formula, you are given a formula, and you'll use the periodic table to find all the numbers you need to add everything together. If you do not have your periodic table, check Google Classroom. There is a copy of one that we use in class. Okay, so on the left here, I have all the steps we need to find our conversion factor that is going to be our molar mass. And I'm going to go through these steps with you as we do an example problem. Okay, so our example formula is H2O, given to you right off the bat. You don't have to find anything. All we're going to do is find our numbers for H2O. So our first thing is to list out the elements in your formula. We're going to break down our formula here. We have a hydrogen and we have oxygen. Okay. Next, find the average atomic mass for each element from the periodic table. Those, right, you will look at your periodic table as the number at the bottom of the square for each element. For hydrogen, we have 1.008. And for oxygen, the number there is 15.999. If you remember from class, it's the only one that I'm going to let you guys round just to 16 flat to make everything a bit easier. Step number 3 is to multiply this number that we just found by the amount of each element in our formula. So we have 2 hydrogens. The subscript of 2 lets us multiply hydrogen by 2. And oxygen here has no subscript, so it's just times 1. Alright, so step number 4, after we multiply these together, we're going to add everything up. So when we multiply, we get 2.016 and just 16 flat for oxygen. We add both of those up and we get 18.016. And at the very end, step number 5 is to set this answer equal to 1 moles. So the amount that we just found is how many grams, okay, so 18.016 grams of H2O, and that is equal to 1 mole of H2O, okay? This is our molar mass. If you notice, it looks just like the conversion factors that we have used in other problems. It's an equivalent statement, so we can turn this into a fraction that goes in our dimensional analysis chart, depending on what unit we have to start with. Right, that determines which side of this equation will go in the top and bottom. So let's do some more examples here. Our next one that we have, if we have this formula, AgNO3, silver nitrate. Again, list out all our elements. So we have Ag, N, and O. All right, we find our average atomic mass for each element from the periodic table. So you guys are doing this, you're looking at your table, finding that number at the bottom, just writing it out. Remember to include all the numbers there, all the way out to the 3rd decimal point. Nitrogen is 14.007, and again, oxygen is rounded to 16 for us. Step number 3, multiply the average atomic mass by the amount of each element. So we look at our formula, Ag, no subscript, so that's just times 1. N, no subscript, just times 1. And oxygen, there is a 3 subscript, so multiply that by 3. These numbers are going to stay the same here. Just rewrite them so you can see every step of this. 16 times 3 gives us 48. That brings us to step number 4. We're going to add all of these together. The number we get is 169.875. And step number 5, we're going to set that equal to 1 mole. So our number 169.875, this is grams of silver nitrate, AgNO3, is equal to 1 mole AgNO3. No matter what this number is here, it's always going to be equal to 1 mole of our formula. Okay?